We're going to talk about the primary trig ratios, which you've done already, which were sine, cos, and tan. Now, the primary trig ratios in grade 10, when they were taught to you, were taught as so. Ka. And everyone forgot the theta, so you were just spelling cos and sin. Adjacent over hypotenuse. Remember, if you write cos, sine, or tangent, they always have to have an angle beside them, right? Or else they're just a word. They're not actually a mathematical trig ratio. They need an angle, like a physical 32 degrees or something, or an angle symbol. SOHCAHTOA. And a lot of you will drop that theta off. You cannot, or it's just a word. I'll write on your paper every single time this is a word. This is not actually a trig, math, anything. Okay. So how did we get these to become y's, x's, and r's? Well, because now we have it rotating about a unit circle. So if we look at, say, 30-degree angle on our unit circle, that's going to be terrific. It's not great. Okay. So here's our 30. It's right here. We agree? So this is the 30. Yes? Okay. So if we did sine, we would normally do opposite of that angle over the hypotenuse. The hypotenuse is the only thing that doesn't change. Hypotenuse always remains the same. It's 1 across from the 90. We agree? So this here would be my hypotenuse. We agree? But that's also what on the unit circle?
Radius.
The radius. Okay? Now, this would be my opposite of this angle. But on the unit circle, it's also what value? The y coordinate. And then this would be my adjacent because it's one beside it. But this would also be my what in the unit circle? My x. So when you're looking at it in an actual Cartesian plane, which is what we now look at all of our trig ratios on, is a Cartesian plane, your adjacents always are x's, your opposites are always y's, and your hypotenuse is always your radius. So our adjacent is our x value, and our opposite, because our opposite and adjacent, you know, they always change, right? On a triangle, they change depending on what angle you're finding. The catch is the angle we're always using is that central angle. So our y is always our opposite, because we're always looking at the central angle. We're never, ever looking at this angle up here, which would then make our x the opposite, right? We never look at that one. So that's why our y's always remain opposite for us. And then our hypotenuse is actually our radius. So many years ago, I can't even remember how many years ago, we came up with acronyms that are stupid, but you learn them and you memorize them. So we use sign your resume, cook extra rice, and tan your X box, because all X boxes need a little vitamin D. You know what I'm saying? Nah. So you're like, these are stupid. Cool, in about 2 days you're going to be saying them. That's fine. You'll get on board. They are stupid. I agree. But they work. Right, Joe? Mm-hmm. Totally. Cool. So, my best. For points on the unit circle, the radius is 1, right? So if we look at points anywhere else that aren't on the unit circle, our radius, we'd have to find it. But on the unit circle, our radius is 1. That's why sine is the y value on your unit circle. Because on your unit circle, we'd have sine your resume, right? Well, resume or radius is 1. So that's why the sine is just the y value of your unit circle. And cook extra rice, well, r is 1, so that's why x is the cos of your unit circle. And then tan, you have to do y divided by x, because it's tan your x box. But also, on your formula sheet, it says tan is sine over cos. Okay? So here it says, since cos simplifies to x and sine simplifies to y, you can write the coordinates of p theta as p theta is cos theta, theta sine theta, which we've talked about already. All of the ones on the unit circle can be written as cos theta sine theta for Calgary Stampede. Cool. That's nothing new-ish. Then we find out there's 3 more secondary trig ratios, which are besties with the primary trig ratio. So cotangent, it's pretty easy to figure out that it goes with tangent because it has the word cotangent in it, like tangent here. So it goes by COT, cotangent, and cotangent is 1 over tan. Well, let's work at that. Let's look at it. So cotangent theta equals 1 divided by tan, because it's just the reciprocal trig identity. Reciprocal trig identities are 1 over something. We agree? Well, tan we know is tan your x box. So now we're going to divide by y over x. And when we divide by a fraction, what do we actually do? Multiply by its reciprocal. So you actually just get x over y. So the secondary trig ratios are just the reciprocal of the primaries. So if it's tan your x box, cotan is x box your. They just flip. They're just the trig ratios. So these are answers that flip. Angles don't flip, answers flip. So if we look at cosecant, cosecant goes with sine theta, and secant goes with cos theta. They're easy to remember because S doesn't go with S and C doesn't go with C. But if you forget, on your formula sheet, it shows it to you. It says that cotangent is cos over sine, but it says here cosecant is 1 over sine, and secant is 1 over cos. So it literally tells you what they are, right? So if you forget what your formula sheet tells you. So, we're on the notes from last day as well, and these. So, cosecant is r over y, because sine is y over r. Do you see that? They're just the reciprocal trig identities of each. And then cos is cooked extra rice, so secant is rice extra. Just the reciprocal trig identity. Okay? And then we talk about cast rule, which you guys have already talked about. It starts in quadrant 4 and goes around. C-A-S-T. Some people like not calling it cast. They like saying, starting in quadrant 1 and saying all students take calculus, but that's not true. Okay. Memorize it that way if you feel the need. The catch here is that we know all 6 trig ratios are positive here, right? All 6 of them. Do you actually need cast if you understand the unit circle? No. No. In this quadrant, all of our coordinates are positive, positive. We agree? Yes. And your radius is always positive because radius is a standard of measurement. So it has to be positive. It's a length. Okay? Well, if I take x divided by r divided by y, or y divided by x, or x divided by y, or any of those, am I going to get any negative fraction? No. No, that's why they're all positive here. Okay? For sine in quadrant 2, we have a negative x and a positive y. So any trig ratios that contain x are going to be negative. Correct? So tans, cotans, coses, and secants are all going to be negative because x is negative. Now, why is sine not negative? Because it's y over r, and y is positive, and r is always positive. So that's why sine and its friend, cosecant, which is r over y, will be positive, because it has to be, because just fractionally putting symbols, correct? Now look here. Now here we have a negative x and a negative y, okay? So tan's the only thing that's positive, which also means cotan's positive. Why would that be? Because it's going to be a negative divided by negative, right? Tan is tan your x box, so it's y divided by x, negative y divided by negative x, positive. Cotan is x over y, negative x divided by negative y, positive. If I pick any other trig ratio, I'm going to end up with something negative, like cos, let's say. Cos is going to be x, negative x divided by r. Sine is going to be negative y divided by r. R is positive. You're always going to get a negative. So yeah, we have these fun cos, all sine, whatever, cast, or all students take calculus, little acronym. But reality says you should be able to reason it through trig ratios that what's going to be positive, what's going to be negative. And here we have a positive x and a negative y. So weird, cos is positive. Yeah, because cos is x over r. R is always positive and my x is positive in this spot. Correct? Well, tan is going to be negative because it's x divided, y divided by x. which is negative divided by positive, right? So it should reason itself through cast. It shouldn't just be something memorized. You should understand why it is the way it is. Okay. So here we have, given the following point on the terminal arm of some rotational angle. Does it say that it has to be on the unit circle here? Does this one say on the unit circle? No. If it said on the unit circle, we could assume R was 1. We agree? Does this say on the unit circle, though? No. So you have to watch yourself. You can't be like, oh, cosine sine and da da da. No, it doesn't follow any rules of unit circle unless the radius is 1. So we just want to find the 6 trig ratios. We're not going to worry about the rotational angle for now. So this is an x and this is a y. I'm given a coordinate. What's the first thing I should maybe do to try and help myself out? Pardon? Put x and y and then draw it. Yeah, you guys are right. So we're going to go -2. -2 and -6. Now, I told you that we will always use central angles in all of these questions, correct? We're also always going to use bow tie angles. So am I going to draw my triangle towards the y-axis or my triangle towards the x-axis? X-axis. And we always use central angles. So it's going to be like this. Ooh, pretend that's a straight line. It's like this, and then we draw towards our x-axis. Otherwise, is it not sticking? So that's our triangle. Guys, what's going to be positive here? What trig ratios? Tan and cotan. So tan and cotan are going to be positive. Therefore, all the other 4 should be negative. If they're not, we messed up. You agree? So let's label our triangle. So we can keep our triangle there. We can label it. My x equals -2. My y equals -6. How for art thou might I find my r? Yeah, Pythagorean theorem. Now, when we do Pythagorean theorem, we're always going to take the square root physically with our arm, right? And when we do this, we put plus or minus. We agree? Now, the cool thing about if it's the radius, it's always positive, so it doesn't matter. But if we're missing x or y, we actually have to find out by drawing it in what quadrant if it's a positive or it's a negative, right? But radius is always positive, and that's what we're dealing with right now. So we're going to find that first. We're going to go r squared equals x squared plus y squared. So -2 squared plus -6 squared. R squared equals 4 plus 36. R squared equals 40. And then we don't need that right now because we're not typing anything in. So R equals positive. Oh, we're back to grade 10. I know you were shocked. I know you were really sad because as of this point we haven't talked a lot about grade 10. We're back to grade 10. The trig ratios from grade 10 as well. Root 40, how do I break that down?
4 and 10.
4 and 10. And I put an equal sign, right? Because root 40 equals root 4 times 10. The 4 comes out and it becomes a 2. So this equals 2 root 10. You're going to use it, if anyone's going to be an engineer, you're going to use all of this.
Why? Because triangles are cool.
Because if you're trying to find any shapes, like whether you're building bridges or you're building buildings, you need to be doing math, all of it. Triangles and shapes and derivatives. You're not going to like round the decimal. That is not going to be what you're going to do on a bridge. Please don't round the decimal. Kaput. Bridge done. All right.
So, yeah, round down. And instead of building your
How about we don't
steel, build a cardboard.
Cardboard. You know, rain doesn't more affect it.
It'll be under concrete.
It'll be cheaper. All right. So let's do our trig ratios. So we have sine. If I do this, which a whole bunch of you are going to do, what do I have sitting on my page? A lot of sin. That's what all I have. I need a theta. Now I actually have sine. Okay? So sine theta is sine, what? Your resume, which you don't actually do. That's totally fine. Sign your resume. So my resume is 2 root 10. So it's going to be -6 over 2 root 10. And sign your resume. Can I reduce anything? Take a 2 out of both of these. What else do I have to do?
Get the thing on top.
Get that thing on top. Rationalize the denominator. Yeah. So now I'm left with -3 root 10. And then root 10 times root 10 is root 100. So that's then we have cos. Actually, I'm not going to go to cos next. What should I go to next, do you think? What's his friend with, yeah, cosecant. It's cosecant. If sine is your resume, cosecant is resume your, right? Resume your. So it's just going to be 2 root 10 over -6. It's just the reciprocal. The layman's terms definition of reciprocal means flip. Don't ever use that as the definition. It's not really clear, but you flip it, invert it, right? And flip it. So this one we can cancel off. And I had a battle with someone one day, and they're like, "You cannot write it like this." Or actually, you can write it like that. You could also write it like this. You could also write it like this. Are any of those wrong? It's just a floating floating negative sign, right? It can be in the denominator, it can be out front, and it can be at the top. It can only be one.
Some of them look dumb.
Hmm?
Some of them look more dumb than others.
Yeah, some of them look less like mathematically correct.
Could I put the negative sign underneath the square root? No. You could not.
No, you could not.
It'd be kind of fun.
Only you would find that funny. Everyone else would be like, "Oh, right, there's a negative sign. Cool."
Yeah.
So I'd be like, "So funny."
Yeah. That's exactly what
I know you would. That's hilarious. Okay. Cos is cook what? Extra rice. So that you could maybe make some chicken fried rice after or something, you know, or maybe you could make a casserole. I don't know. Options. So we always cook extra rice. So what is our x? And rice? 2 over 10. The 2's can cancel. And then you multiply by root 10 to rationalize the denominator. And we get negative root 10 over 10. What should we do next? What's its Betsy? Secant. So secant, if this is cooked extra rice, this is rice extra. So you just get 2 root 10 over -2. Would I ever, this isn't wrong, but would I ever leave it like that? No, you'll never see it like that. What will they do? Just move the -1 up, right? And then tan is what? Tan your Xbox to get it, vitamin D. Very essential for life. Okay, tan your Xbox. Wait a second. It's positive. The other ones are negative. Oh, right, we said that. Because, yeah, we wrote that here. Oh, my goodness, look at this. Look at this garbage. Jeez. Who am I thinking I am not writing the theta? Creating bad habits. Shame on me. All right. And then tan goes with cotan. If tan your Xbox, then this is Xbox your, which is a third. So it's literally just what tan is flipped, right? We could essentially do that. Does this make sense? Now we couldn't just use the 1 because as for our radius, because it didn't say it was on the unit circle, right? If it said it was on the unit circle, we could use the 1. Okay. I want you guys to do number 2, then we're moving on to something different. The first thing we're going to do is draw it. This one's a lot faster because it doesn't have any negatives, so you don't have to rationalize. I mean, not negatives, radicals. So we're at 3 and -4, and we draw towards the x-axis with central angle here. So our x equals 3, our y equals -4, and our r is going to equal 5, and you'll see this often coming up, but 3 squared plus -4 squared, r squared equals 9 plus 16, r squared equals 25, and then when I physically take the square root, when I do this with my hand, I have to remember to put plus or minus. Now with r, it doesn't matter because you know it's positive, but we're not always going to be just finding r. We will be missing x or y and have to find them as well. So r equals 5. So then we do sine, check your stuff, make sure you have a theta in it. Okay, hold on to you who did not write thetas the entire time. Watch yourself. So sine your resume. So I get -4 over 5. What's positive in this quadrant? Cos theta and its bestie, which is secant. Because it's just its filter version. So sine and then cos theta is going to be 5 over -4. Or -5 over 4, or negative 5 over 4, right? Like, you can write however you want. That's not supposed to be cos. That's supposed to be cosecant. Okay, cos theta took extra rice, so we get 3 over 5, and it's positive, which it should be. Secant will be rice extra, so it'd be 5 over 3. Tangent is tan theta, tan your x box. So it's -4 over 3, which is negative, which it should be, because only cotan and secant should be positive. And then cotangent is its bestie, with its reciprocal trig identities. You can write it like this, you can write it like this, you can write it like this. They all the same. Right? Okay, so we're going to bypass some stuff here. We're going to go past you. We don't want to see you right now. You're going to overwhelm us. We're going to go here. So, they want the exact value of some trig ratios. That screams, go to my unit circle and pull values off. Now let's talk about our unit circle for a second, because you're going to be able to do all of these. Let's talk about our unit circle for a second. We go to our unit circle. Let's pull this value off. So if this is 30 degrees or pi over 6, what would I write as my coordinate, guys? Rather than root 3 over 2.5, what could I write? Cos, 30. Sine, 30. Is that true? Okay. So I talked to you about this. I could find tan as rel. Yep, as rel. Totally. So tan theta, if we don't remember, it's tan your x box, so it's y over x. Or you could go in there and say, oh, it's sine over cos, correct? On our formula sheet, it tells us that. Yeah. So we would just take sine 30 divided by cos 30, and I'm writing it sideways to be a fraction. Well, what would cotan be then? Cotan would be cos 30 divided by sine 30. Okay, cool. So from the unit circle, I've been able to find 4 trig ratios. Cos 30 is the first fraction, sine 30 is the second fraction. Tan 30 is going to be tan theta. Tan 30 is going to be sine 30 divided by cos 30. Cotan 30 is going to be cos 30 divided by sine 30. How do I get secant of 30? What is secant of 30? On our formula sheet, what does secant say? 1 over cos of 30. So what does that mean? Find cos of 30 and flip it, correct? So instead of it being root 3 over 2, I would write 2 over root 3. And cosecant 30 will be 1 over sine 30. Sine 30 is a half, so what would cosecant 30 be? 2 over 1, right? So you can pull them all off your unit circle, every single one of them. Secants and cosecants sometimes a little more work, so you have to rationalize the denominator. But your most amount of work often comes from tans and cotans because you have to divide fractions, right? Okay, we'll go into seeing a pattern after. For right now, we're going to do these. Let's go back down to here. Tan of pi over 2. Can I pull tan right off my unit circle immediately? Can I go there and say it's a half?
No.
No. What do I have to do? Tan is what over what? Sine pi over 2. Then? Divided by cos pi over 2. Okay, what's the y at pi over 2? What's the y at pi over 2? Pi over 2 is your 90. 1. And what's the x, or the cos? What's the cos? Now, did I have to write these sideways? Are these actual fractions? No, the only ones you don't have to write sideways are like the 90, 180, 270, 360, because they're just ones and zeros. So this is actually 1 divided by 0. What happens when we divide by 0?
Error.
Error is what your calculator is going to say. So you're going to say undefined. So what actually happens at tan of pi over 2, you get an asymptote. It's one of those dashed lines. It's a line that doesn't exist. Cosecant is 7 pi over 6. So go to 7 pi over 6. What's the coordinate at 7 pi over 6? I want you to tell me it.
Negative root 3 over 2, comma, negative 1.
Yep. Okay. Cosecant goes with which one? Sine or cosine? What does cosecant go with? Sine or cosine? Sine. So that's what I'm going to box. So that would be the answer. That's a lie. Wow. Just ignore that. It didn't happen. Okay. So sine, the answer to sine of 7 pi over 6 would be negative a half. We agree? We're going to write that to help ourselves out for now, because we need to do this at the beginning, then after it makes sense and we can do it without doing this. 7 pi over 6 is a half, negative a half. So what then is cosecant of 7 pi over 6? Equal to? Negative 2. Do you see how we're just flipping the other one? Because it's the reciprocal. Reciprocal means inverse, means flip. Okay, sine of negative 300. What's its coterminal? If we still want to. Sine of 60, what did you do to get that? Added 360, because it terminates on the same spot, correct? Negative 300, 60, all terminate on the same spot. I have to get these tonight so we can put them. 300 is here. Oh, it's negative 300. It's here. Oh my gosh, it's slightly hard piece of paper. Which is also in the same spot as 60. Do you agree? Just terminates in the same spot.
Makes sense.
Makes sense?
Yeah.
All right. So sine 60. So what is sine at 60?
Like root 3 over 2.
Mm-hmm. Can you check all of these?
Hopefully.
Yeah, you can. You can type every single one of those questions in. How would I type in cosecant, though? Let's go back to this one. How would I type this one in? Go to my formula sheet. My formula sheet says cosecant is what?
1 divided by sine.
1 divided by sine. I have a sine button, correct? So I'm going to go 1 divided by sine, and then I slap my hand and I say, oh, darn it. I need to be in radian mode because I'm going to type a radian. So type that in radian mode. And what do you get as an answer? Negative 2. So can we check these always? Yes, we should never walk away from any of these questions and not check them. Okay, secant is 60. what do I need if I'm doing secant?
1/3.
I need cos of 60, right? What is cos at 60? What's cos at 60? I basically have it written. 1/2. So what's secant at 60? 2. How could I type in secant 60? Let's practice it. What would it be? 1 divided by cos of 60 degrees. But this time I'd have to be in degree mode. Okay, I'm having you guys try. Look at this. So many. The only one I want to draw your attention to is this little one with a square in the middle. Press the cos button on your calculator. What immediately happens? A bracket opens up for an angle, correct?
Yes.
Which would be 225. Is that not true? How am I going to fit a squared in there? I'm not. I'm not going to put a squared in. I can't fit a squared in. So what they do is they put it like this, because this means that the cos is actually squared. If they wrote it like this, that would mean the 225 was squared, correct? So it becomes confusing. So what they did is they wrote the squared in the middle. All this is it's the same as this for you guys with your calculators. It means you find the answer to 225 and you square it. That's all it means. So when you go to type into your calculator, you'd actually have to type it in brackets and then square your answer. Okay? So there's all the way to P. Giver. Cos 150 is the x at 150, which is negative root 3 over 2. Sine at 315 is the y at 315. What's that going to be? Negative what? Root 2 over 2. Sine negative 30, you can visualize it if you want to, or you can just add 360 to it and know that it terminates the same spot as 330, which is going to be negative a half. Tan 240 is the same as sine 240 divided by cos of 240. Sine at 240 is what? Negative root 3 over 2 divided by negative a half, I believe. Negative root 3 over 2 times negative 2 over 1, which is root 3. Tan 480, if I want, I can subtract 360 from it. So I'd subtract 360, I get 120. So it's going to be sine of 120 divided by cos of 120. Sine of 120 is root 3 over 2. Cos of 120 is negative a half. So I get root 3 over times negative 2 over 1. And I get negative root 3. Cos at 225 is negative root 2 over 2. But then I square it. When I square a negative, what happens to it? Square a negative, it becomes positive. Square a square root. Square root goes away, right? And then square the 2, you get a 4, so it's a half. Sine of 5 pi over 3. Sine 5 pi over 3 is negative what? 60-degree reference angle. Tan of 7 pi over 6 is the same as sine of 7 pi over 6, which is 210 divided by cos of 7 pi over 6, which equals negative a half divided by negative root 3 over 2, which is negative a half times negative 2 over root 3. 2's cancel, and I'm left with 1 over root 3. Am I done?
No.
No, I have to rationalize. So I get root 3 over 3. Negative 2 pi over 3 is too small, so I'm going to add 2 pi to it. When I add 2 pi, I'm going to have to multiply by 3. So I get negative 2 pi over 3 plus 6 pi over 3, which is 4 pi over 3, which is on my unit circle, and terminates in the exact same spot, so I can find cos of 4 pi over 3, which is negative, what? So I started with a 1.
That was, I knew that.
Sine of negative pi, you can either visualize it and go to negative pi by reversing your arrow, or you could add 2 pi to it and it would be the same answer as sine of pi. What is y at pi? 0. And then negative 5 pi over 3, I have to add 2 pi. So I get negative 5 pi over 3 plus 6 pi over 3, which is actually the same as pi over 3, or 60 degrees. And cos at pi over 3 is, and then tan of 2 pi over 3, we would have to find first, so we go sine of 2 pi over 3 divided by cos of 2 pi over 3. So sine of 2 pi over 3 is a 60, so it's going to be root 3 over 2 divided by negative a half, which is root 3 over 2 times negative 2 over 1, which is negative root 3. So if you haven't noticed, the 60-degree tans all come out as root 3s, and the 30-degree reference angles come out as root 3 over 3, and the 45s come out as 1s. Because all the 45s would just be root 2 over 2, root 2 over 2.
Can I just square that though?
I don't know what you're talking about. It's totally getting squared. It's even boxed. I can't. I just can't. I have to fix that. Oh, no. Go back. Undo. Go back. Oh, okay. I guess that. Yes, I do need to square it. So up here, I should have done this, right? That's not easy. Good catch. Okay, this is your homework.
Don't worry, I actually did it all for like 4 questions. No. Very good.